Good morning, you guys. Welcome back. We are officially starting chapter 6 today. So go ahead and find your new math journal. We're on volume 2 now, and we're on page 329. We are going to be talking about equivalent fractions. So we kind of already talked about this during morning reading, but remember that a fraction just means part of something. So if I were to tell you I ate a fraction of the pie, that means I ate part of the pie. And when we talk about equivalent fractions, we're talking about fractions that are equal to each other. So equivalent just means equal. And so today we're practicing finding fractions that are equal to each other using two different methods. So the first method we're going to talk about is using models. So go ahead, we're on page 329. You need your pencil, and you might want a colored pencil so that when we shade in the model, it kind of stands out to you more. But if you don't have colored pencils, you can use just your regular pencil. Again, whenever you feel confident, you should go ahead and pause the video and try whatever you can on your own, and then come back and check your answers at the end to make sure you really got it. So number 1 and number 2 say, use the model to write an equivalent fraction. So the first one is showing 1/5. So the whole picture is cut into 5 equal parts, which is where I got the fifths. And since one part is shaded in, the fraction is 1 out of 5. And so next to that, we're going to try to now cut fifths up into more pieces to make an equal fraction. So think about this. Do you see a way that you can cut this box into more pieces than just 5 equal parts? Each of the pieces have to be equal to each other, though. So there are probably multiple ways to do this. The one way that I see that just kind of stands out is if you take your pencil or your colored pencil and you slice the box in half like this. Can you see that now instead of 5 equal parts, so instead of fifths, now if you count, I'm outlining them to kind of show you, there are 10 equal parts. So instead of fifths, when you cut that box in half, now there are tenths. And originally there was 1 piece out of 5 shaded in, but now when we split our box into tenths, do you see that in blue there are 2 pieces shaded in? So an equal fraction to 1/5 is 2/10. Okay, go ahead and try number 2 now. This one is showing 2 parts shaded out of 3 altogether. So the long rectangles show thirds. Can you split the thirds up into more pieces? Again, I see one way to do it is just straight down the middle. Now instead of thirds, there are 6 parts. So we're talking about sixths. It's hard to say. And instead of 3 pieces shaded in, can you guys see that there are 1, 2, 3, 4 pieces shaded in instead? So 2/3 is equal to 4/6. So one way to think about this is think about equivalent fractions is just using a model like we just did. But some of you might see a pattern, and this is what we're going to practice in the next part. So let me kind of show you. On number 1, I'm going to write the 2 fractions up here to show you the example. 1/5 we said was equal to 2/10. Can you see how those fractions are equal to each other? Or can you see a pattern between 1/5 and 2/10? You might see that all you were doing is you're doubling or multiplying by 2. If you do 1 times 2, you get 2. 5 times 2 is 10. So because they're both multiplied, the numerator and the denominator are both multiplied by 2, I know that 2/10 is equal. So another way to make equivalent fractions is by picking a factor. In this case, I chose 2, and multiplying the numerator and the denominator by that same number, and it'll make an equal fraction. So jump down to number 3. There's not a ton of room down here, but I'll kind of show you what I mean off to the side. So it says, tell whether the fractions are equivalent. Write equals, or that symbol with the line through it means not equal. So number 3, I'm going to write it off to the side so you can see 1 over 6 and 2 over 12. You have to decide if they are equal or not. So think in your head, is there a number that's being multiplied, the same number, in the numerator, the denominator, to get the second fraction? Are you doing, on the top, you're doing 1 times 2 to get 2? Oh, I wrote the wrong number, sorry. It should say 2 over 12. And then if you do times 2 on the bottom, 6 times 2, do you get 12? Yes, since on the numerator, the top and the bottom, you did times 2, these are equal to each other. But then, now look at number 4, for example, 2/5 and 6/10. 2/5, 6/10. So think about your math facts. 2 times what? This is like a puzzle, equals 6. 2 times 3 is equal to 6. So on the top, in the numerator, I multiplied by 3. Now, in the denominator, see if the same is true. If you do 5 times 3, do you get 10? No. So that means that these are not equal to each other, because on the bottom, whoever did this was doing times 2. Since these factors are not the same, then the two fractions are not equal to each other. And that's basically how you can tell without a model whether the fractions are equivalent or not. Number 5 and number 6, they're the same thing. They're just kind of written backwards. Let me erase that for a minute. Okay. So number 5, 4/12, 1/3. Okay, so you might need to go backwards and do this. 1 times what is 4. So they were doing 1 times 4 equals 4. Did they do that same thing on the bottom? Is 3 times 4 12? Yes, so that these two are equal to each other. Number 6, though, 5 over 8 and 2 over 4. So try. Think about 2 times what is 5? Nothing, actually, because 2 times 2 is 4, 2 times 3 is 6. So this one, they can't be equal to each other, because 2 times nothing is 5. So they're not equal. Number 7, 5/6 and 10/12. 5 over 6, 10 over 12. Alright, so 5 times 2 is 10. Did they do the same factor on the bottom, times 2? Yes, so these are equal. And then number 8, they were doing on the top, they multiplied by 5. Is that true? On the bottom, 2 times 5 is 10? Yes, so these are also equal. Okay, so again, if you know your math facts, this should be a breeze for you because the patterns are easy to spot. If you don't, that's why you guys are doing extra math this week. Yay! Okay, so jump down to the bottom part. These are not difficult, they're just kind of wordy. Go ahead and try them on your own though if you want. It says Manny used 8 tenth size parts to model 8 tenths. Okay, I'm just going to go ahead and draw what that looks like. Here's Manny. He is modeling 8 tenths. I'm going to use a rectangle. Two, three. All right, that should be 10. He wants to show 8 tenths. Okay. Okay, so in yellow, that should show 8 over 10. 8 tenths are shaded yellow. Then it says Anna used fewer parts to model an equivalent fraction. Okay, so that means that instead of using tenths, can she use fewer parts to model the same shaded amount? So can you break Manny's model up? It's in 10 pieces. Can you break it up into a fewer number of parts, but still show the same yellow part shaded in? Think about that. You might have to kind of play around for a minute. I see, you can break this into fifths. If you take 2 of Manny's rectangles, I'm going to do Anna or Anna in blue. I see that instead of tenths, the same model can be broken up into fifths. So take 2 of Manny's pieces and stick them together to make one bigger piece. Can you guys see how I'm making fifths in blue? If you can, think about how many pieces now, how many fifths are shaded yellow. Here is 1/5, 2/5, 3/5, 4/5. So originally, up at the top or the middle section, I said we would go backwards kind of and do 4 times what equals 8, but you can also use division facts to do this. Since it said she wants to use fewer parts, you could be talking about dividing. So you could think about dividing. 8 divided by what would give you 4, which is 2. 10 divided by what is 5, which is 2. So I know that those are equal. So when we talk about using factors, you could either multiply or divide by the same factor. So to answer the question, how does the size of a part in Anna's model compare to the size of a tenth size part? The blue boxes are bigger than Manny's original little gray rectangle or black rectangles. So I'm going to say that a part in Anna in her blue model is bigger. And what size did she use? She used fifths because I was able to cut it into 5 pieces instead of 10 pieces. Okay. Then number 10 says, how many eighth size parts do you need to model 3/4? Explain. So go ahead and draw 3/4. You can draw another rectangle. Those are fourths. 3/4 would look like this. Okay, but now it says how many eighth size parts. So right now the model shows fourths. Do you see a way that you could split it into 8 parts instead of 4 parts? If you cut it in half like this, the blue line, now it shows eighths. So originally it had 3/4. You want it into eighths. It says how many eighth size parts do you need to model? So how many shaded in? 1, 2, 3, 4, 5, 6. And again, when we talk about factors from 4 to 8, you're just doing times 2. So if you do that same thing with the numerator, you get 6. So how many parts? 6. Because if you think about this, when we talk about a fourth, if you put 2 of the eighths together, it equals 1/4. We needed 2 eighth size parts to equal 1/4 size part. So it was like we're doubling it. Instead of 3/4, when we double it, now we have 6/8. Okay, when you're ready, go ahead and turn the page to 330. We're talking about pizzas. Ben brought 2 pizzas to a party. He says that since 1/4 of each pizza is left, the same amount of each pizza is left. What is his error? So this is just something you guys need to keep in mind. So in this example, Ben has a circle pizza and he has a rectangle pizza. Each one, originally you can kind of tell, had 4 pieces. There's only 1 piece left, so that shows 1/4. However, that doesn't automatically mean that they're the same size, because if you look at the 2 pictures originally, the pizzas were not the same size. So since the original pictures or pizzas were not the same size, 1/4 is not equal on both pizzas. So Ben's error was that the 2 pizzas are not the same size. So 1/4 of, let's say, the circle pizza is not equal to the other one, to the rectangle, because the circle is a different size than the rectangle to begin with. So when you compare fractions, they have to be, the original pieces have to be the same size. So part B says, draw models of 2 pizzas with a different number of equal slices. Use shading to show 1/4 of each pizza. Okay, so since we're talking about 1/4, I'm going to go ahead and draw what they already did with the circle. All right, here's my really good circle. We're talking about 1/4, so cut this into fourths. Shade in 1/4. So there's 1/4. That's one pizza. Then it asks you to make another pizza, so it has to be the same size to compare them. But it has to have a different number of slices. So if you guys know what a real pizza looks like, usually it's cut up into 8 slices. So start with the 4. And then if you draw up kind of an X in it, it'll make 8 pizzas. 8 pieces. And then if we want to shade in 1/4 of that, so the same amount as the first pizza, instead of shading in 1 slice, we have to shade in 2. So this is showing that 1/4 is equal to 2/8. And if you think about the factors, we just doubled it. So 1/4 and 2/8 are equal. All right, if you have not already tried any on your own, go ahead and try the last 4 on your own. It says, tell whether the fractions are equivalent by selecting the correct symbol. Okay, so pause here, try them on your own. You can show your work wherever you have room. Oops. Check back at the end, see if you're right. All right, so for letter A, 3/15 and 1/6. So think about, how did you get from 3 to 1? You can either do multiplying or dividing. 3 divided by 3 is 1, actually. So then check on the bottom, is 15 divided by 3 6? No. 15 divided by 3 is 5. So these are not equal. Letter B, 3/4, 16/20. How did you get from 3 to 16? I know that 3 times 5 is 15. 3 times 6 is 18. So you really can't do 3 times something to get 16. So because of that, I know right away they're not equal. Letter C, 2/3, 8/12. 2 times what is 8? 2 times 4. Is that true in the bottom, that 3 times 4 is 12? Yes. So these are equal. And the last one, 8/10 and 4/5. I think we did this on the other page. But how did you get from 8 to 4? We're not multiplying or dividing. So 8 divided by 2 is 4. Is that true on the bottom? 10 divided by 2 is 5. Yes, so these are equal. All right. We are going to go ahead and stop there for today. I know that sometimes finding equivalent fractions might be kind of confusing maybe if you don't see the pattern right away. So please let me know if you need help with this or you have any questions at all. I'd be more than happy to help you guys. Otherwise, I will talk to you soon.